Hello everyone, this is Karthikeyan. I am a candidate master on Code Forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27, Global rank 251 in Google Kickstart Round Day 2021. And today I am going to discuss the problem cache hits, which was asked in June Cook-Off 2020. The difficulty level of the problem is Cakewalk. The prerequisites are basic math, and the number of submissions this problem got during the contest were 5,931. So now let's move on to the problem statement. Here is the problem. Chef has a memory machine. It has one layer for data storage and another layer for cache. So basically there is a memory machine in which there are two layers. One layer is for data storage and the another layer is for cache. Okay. Now Chef has stored an array with length capital N in the first layer. Now in the first layer, which is the data layer, there is stored an array of length n. Now let's denote the elements of the array by A0, A1 till A of n-1. Now the elements of the array are indexed from 0 to n-1. Now he wants to load some elements of this array into the cache. So Chef wants to bring some elements of the array which is stored in the data layer to the cache layer. Okay. Now the machine loads the array in blocks with size b. So a whole part of the array cannot be loaded into the cache. See, the whole array is present in the main memory. Now, the whole array cannot be loaded into the cache, but blocks of size b of the array can only be loaded in the cache. Now, if the size of the block is b, then either indices from 0 to b-1 form a block, or indices from b to 2b-1 form another block, and so on. So starting from the index number 0, the first b indices form the first block, the next b indices form the second block, the next b indices form the third block. Okay, and in this way the last block may also contain less than b elements of the array. Suppose that the block size is 5 and we are having an array which consists of elements from 0 to 13. So the first block would contain elements from 0 to 4. The second block would contain elements from 5 to 9, okay, and the third block would contain elements from 10 to 14, but we are having elements only up till 0 to 13. So the last block is of size 4 rather than being of size 5. So that is what this points mean. The cache may contain at most one block at a time. See, the main memory can contain the whole array at once, but the cache can contain only one block of the array at a certain time. It is not possible that the cache has 2 blocks or 3 blocks. It can have 1 block of the array at a time or 0 block of the array. Okay, now whenever Chef tries to access an element a of I, the machine checks if the block where a of I is located is already in the cache. And if it is not, loads this block into the cache layer so it can quickly access any data in it. Now, if we want to access the element I, then this element I belongs to a block of the array. Now, since the cache can contain at most one block, so if the block to which this element I belongs is same as that of the block which is in the cache, then there is no problem. We can just go to the cache, access this element from the block, and our job is done. But if the block to which this element belongs is not in the cache, then we have to load that block from the main memory into the cache. Okay. However, as soon as Chef tries to access any element that is outside the block currently loaded in the cache, the block that was previously loaded into the cache is removed from the cache. Okay. Now, since the machine loads a new block containing the element that is being accessed. Okay. Chef has a sequence of elements a of x1, a of x2 till a of xm, which he wants to access. So basically we are given m queries. These m queries are only indices, denoting the indices of the elements which we want to access in the ith query. Okay. Now suppose that if we want to access an index idx, now there must be a block in which this index idx is belonging. Now, if that block is currently loaded into the cache, then there is no problem. We can go to the cache, access that particular index, and our job is done. there is no need of reloading the cache. But if the block to which this index belongs is not in the cache, then we need to reload the cache. We need to bring the block to which this index belongs and we need to empty the cache. We need to erase the current block and need to bring a new block to which the new index belongs. Now, initially the cache is empty. Chef is wondering how many times the machine will need to load a block into the cache layer. So we just have to tell the number of times when a query is asked and the block in which the queried index is contained is not the block which is currently present in the cache. So in that scenario, we have to bring a block in which the current index is present into the cache. So can we help him calculate this number? Okay, so the input format contains a single integer capital T which denotes the number of test cases. Then for every test case, there are three integers n, b and m, where n denotes the size of the array whose indices are from 0 to n minus 1. B denotes the size of the block in which array has been divided into, and m denotes the number of queries. Each query consists of a single index from 0 to n minus 1. And for each test case, we have to tell the number of times the cache needs to be reloaded. Okay. Now let's solve a few sample test cases. So here is the first sample test case. We are having 5 blocks. We are having 5 elements. Okay. And the block size is 3 and we are having 3 queries. So this is what the array would look like: 0, 1, 2, 3 and 4. And since the block size is 3, so this would be our first block and this would be our second block. Okay. Now let's write the cache. Which block is in the cache currently? Currently the cache is empty. Okay. Now what is our query? We query for the index number 0. We query for the index number 3. We query for the index number 4. Now, in which block does index number 0 belongs? It belongs in the first block. Does the first block is present in the cache? No. So we have to load the first block in the cache. Now, so this would increment our answer, which was initially 0, by 1 because we have to load a block in the cache. Now, which is the queried index? The queried index is 3. Now, let's check that to which block this index 3 belongs. It belongs to the second block. Now, is the second block currently loaded in the cache? No, it is not loaded in the cache. So we have to load this block in the cache. So the cache would be reloaded. So our answer would be incremented again. Now, the third query is 4. Now, to which block the index 4 belongs? It belongs to the second block. Now, is the second block currently loaded in the cache? Yes, it is loaded in the cache. So there is no need to reload the cache. We can just go to the cache, fetch the data of the fourth index and our job is done. So the number of times we require to switch the cache is 2. So our answer for this test case would be 2. Now let's move on to the second test case. In the second test case, we are having 12 elements in the array. The block size is 3 and 6 queries. Okay. We are having 12 elements. So they would be numbered from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Just a minute. Just 1 minute. Okay. Yeah. So since we are having 12 elements, so they would be numbered from 0 to 11. Eight and 9, 10 and 11. And the block size is 3. So the first block contains these elements. The second block contains these elements. The third block contains these elements. And the fourth block contains these elements. Okay. Now, initially our answer is 0 because the cache is not reloaded a single time. And initially the cache is empty. Okay. Now, the queries are 0, 2, 8, 1, 5 and 6. These are the queried indices. Now, first the query is 0. To which block the index 0 belongs? It belongs to the first block. Is the first block present in the cache? No. So we need to reload the cache and increment our answer. Now, What is the query? Second query. The second index. To which block the second index belongs? It belongs to the first block. Is the first block present in the cache? Yes, it is present in the cache. So there is no need to reload the cache and our answer won't be incremented. Now, what is the third query? The third query is 8. To which block the index 8 belongs? It belongs to the third block. Is the third block present in the cache? No, it is not present in the cache. We need to load it in the cache and increment our answer. Now, what is the query number 4? It is 1. To which block the index number 1 belongs? It belongs to the first block. Is the first block present in the cache? No, it is not present in the cache. We need to load it in the cache and increment our answer. Now, the query number 5 is 5. Now, to which block the block number 5, the index number 5 belongs? It belongs to the second block. Is the second block present in the cache? No, it is not present in the cache. We need to reload the cache and increment our answer. Now, what is the query? It is 6. Now, to which block the index number 6 belongs? The index number 6 belongs to the third block. Now, is the third block present in the cache? It is not present in the cache. We need to reload the cache and increment our answer. So, we can see that our answer is incremented whenever the previous block or the block currently in cache is not equal to the block to which the current index belongs. Okay, now whenever the previous block is not equal to the block to which the current index belongs. Now, to which block does the current index belongs? If we number the blocks from index 1. So, the current block would be equal to, first of all, we are having a query as index idx. And since index idx is from 0 to n minus 1, so first of all, I would increment index idx to idx plus 1 to make it from 1 to n. Now, to determine that in which block this index idx plus 1 belongs, I would write idx plus block minus 1 upon block. So this would give me the current block of this index. Now, if this current block is not equal to the previous block, then I would just increment the answer and load this new current block in the cache and make the previous block equal to the current block. Previous block denotes the block which is currently in the cache and current block denotes the block to which the current queried index belongs. So this is the approach of this problem. Now let's move on to my code. Here is my code. You can see that T denotes the number of test cases, N denotes the number of indices in the array, B denotes the block size, and M denotes the number of queries. Now, here I have initialized the previous block equal to minus 1 since initially the cache is empty and the answer equal to 0. Now, I take the queried index as input as x and increment x. Now I find the current block to which the index x belongs, which is equal to x plus b minus 1 by b. Now, if the current block is equal to the block which is currently present in the cache, then there is no need to reload the cache. But if it is not equal, then we need to reload the cache. Now, which block would be present in the cache? The current block would be present in the cache. And the block present in the cache is denoted by the previous block. And we have to increment the answer since we reloaded the cache. After this, I would print my answer on a new line for every test case. Let's submit the solution. Okay, you can see that the code got accepted. So if you have any doubt regarding this approach, you can ask in the comment section, and thank you for watching the video.